Cool. So thanks everybody for joining us here on stream. We're really excited to be here on behalf of Frostbite at EA. My name is Afshin. I am a software engineer with the Frostbite animation team. I've been with the team for just under 4 years, and my role on the team is basically the same as every other engineer on the team, which is to develop and foster and support the end-to-end of the animation system in Frostbite that we're going to be working with today.
Hi, my name is Marion Gauthier. I'm the technical animation director with the Frostbite UX and content team, which is a mouthful. I've been in the game industry for about 18 years now. I joined EA 16 years ago, so I've been here for a long time. I started as an animator, and I then became a technical artist, and now I'm a technical animator. And mostly what I do these days is I work with people like Afshin in the Frostbite animation team to develop tools and workflows. I also work with teams who want to adopt Frostbite as their animation engine and advise them on the animation capabilities. And I create training and documentation materials for animators working with the Frostbite animation system.
So we're going to be doing a live demo of Frostbite animation, but maybe we should talk a bit about what Frostbite is if you're not familiar with it. So Frostbite is EA's internal game engine. It has the editor side, it has a data build system, and obviously the runtime that everyone sees in the Frostbite games that are shipped. And there are a lot of domains in Frostbite. We're really going to be focusing on one particular one. The engine's been in development for quite a while. It started off as the engine used for the Battlefield series, and from there it kind of expanded to encompass multiple different types of games. So on the sports side of things, there's FIFA and Madden that are now running on Frostbite. There are a bunch of action-adventure games, Mirror's Edge, Anthem, Dragon Age, Mass Effect, and a bunch more. So the engine's constantly expanding to encompass different types of games. But yeah, today we're going to be particularly focusing on the animation system. So Marion, what's on the slate?
So what I thought we'd do today is I brought in a really simple character. I'll bring him up on the screen here. So this guy here, and a whole bunch of animations. Here they all are. And I thought we'd just spend the hour building something right in front of you. So this is a live demo. Keep your fingers crossed. And along the way we'll show off some of the sort of common general animation tools that animators use every day in this tool. In the second half, we'll switch gears a little bit and show off some of the more advanced tools that animators can use. And along the way, so we'll see what the workflows are like in this tool. You'll get to see how animators generally work. And you'll also get to see some of the power that people have at their fingertips when they work with this, with Frostbite.
Yeah, and you'll really see how content creators and engineers actually work together, towering over a 15-inch laptop display. Okay, so first things first, let's talk about some basics of Frostbite animation that you'll need to understand before we really can get into the meat of the demo. Fundamentally, the core concept that we use a lot is this idea of a controller. So a controller is basically anything, some entity, whose job it is to write the pose at a certain point in time. So to see what this looks like, let's just kind of look at the most basic controller we have in Frostbite. So if I bring in an animation, so this could be something from motion capture or something that's hand animated, something like this. I'll just bring this into Frostbite. What you'll get when this comes in, I picked a big one, sorry. When this thing comes in, this becomes what we call a clip controller. And a clip controller is pretty much just the raw playback of the animation, and now in the Frostbite format. And you could do some other things to it. I mean, you could compress it and add stuff, and we'll see some little things that we'll add to it, markup we can do to it later in the demo. But that's really what a controller is. But see, one of the really key parts about controllers that make them super powerful is that controllers can also be compositions of other controllers. So to see what this looks like, let's look at what we call a sequence controller. So a sequence, we'll create one here. A sequence is basically a controller who is a composition of clips. So if I go over here and in this sequence, let's say I drag and drop a clip. I can just drop it in. Just frame the character here. So at first, this is just playing back this clip. But I can drag and drop another clip in here. And what I'll get is, in that overlap region, a blend of the two clips. And so what I'll get is kind of like this non-linear blend, and I can define what the blend looks like. This is obviously going to look super silly. But the idea is that this controller is now composing itself from all the other controllers, and I can drag and drop many clips in here and whatnot. And so you'll see this throughout, and what's really awesome about this is that from an external perspective, a controller is just a controller. The difference between a sequence and a clip is nothing, so they can be used interchangeably. And you'll really see the implications of that as we go through the demo today. And finally, sort of the controller that encompasses all of it's like sort of the master thing that runs everything is our state machine, which we call the stateflow controller. So I'll hand that over to Mary, and let me just close some things for you to kind of discuss what that's all about.
So stateflow is basically our version of a state machine. And for those of you who don't know what a state machine is, it's basically a node-based graph. The nodes in the graph very roughly correspond to things that you can do in a game, like idling, locomotion, shooting, jumping would be nodes. And then there'll be transitions between the nodes that tell you how you can go from one state to another. And in Frostbite, what the state machine also does is it defines the rules for when you can go from one state to another. So, for example, if I wanted to go from idle to locomotion, usually I'd have a rule that says you can only do that when you're pushing on the stick on your gamepad. So a lot of those rules are basically a part of stateflow and directly built in. So you'll see in a second how that actually works. Okay, so before we start making actual animation, why don't we set up one of those rules, or at least like the input from the gamepad that we're going to use in a second. So the animation editor that I have open here has this nifty system called the input system. And in here, I can create basically hooks into my gameplay controller. And I'll just go ahead and make what's called a game state. This is a variable that has values that I can write to and read from. I'll just call this input dot left stick. Okay, this is a Boolean, so it can be true. It has two values, true and false. And I can just drag this over here into my input system and then hook it up to my gamepad, like so. So here, at the top here are all the buttons. At the bottom, I have a representation of the joysticks. Yeah, go ahead, you do that. And now I can just kind of click here and say, when I'm in this blue area with my joystick, my game state right here is true, and when I'm in the white area, it's false. And we can test this out right in here, so you can see as action is, turn it this way. So as action is moving the stick, you can see there's like little green lines when it's active, and little dark areas when it's not active. So this is really useful if you're a technical animator, you're trying to do prototypes. You can do your own hookups. I don't have to go to somebody like Action to do that for me.
Because I wouldn't know how.
Okay. All right, now that we have that, let's actually go ahead and build something. And I'm just going to go and open a little test level.
And these game states, we'll see a bunch of them throughout. There are various different types of Booleans, floating points, and whatnot, and you can basically write to them and read from them in any point in the animation system, which is pretty nifty.
Okay.
Get the layout working here.
All right, so here's our little test level. Oh, come on.
Just got to tab out.
All right, there. All right, we'll move that over here. All right, so right now our character is in T-pose because he is using the state flow, and this only has one node in it, and the node doesn't contain any animation. So I'm going to first turn on this, which we'll see what that is in a second, and then I'm going to go find an idle animation over here. So this area over here is where all my assets are, and I can access them by type of asset. Sorry, loco, there's my idle. And I'll just drag that over here, and boom. So what's now happened is that as I'm editing in the animation editor, in this live game over here, my edit has immediately been applied to my character. So this is a really nice feature of our tool set where you can get really rapid iteration going for any feature that you're working on, and you can test your stuff like basically immediately in the game.
Nice.
All right, so we have an idling character.
Yeah. Thanks for listening to our presentation. That was, no.
Okay. Do something.
Thanks, that's great feedback. Okay, so let's add some more states to this and kind of get some interesting locomotion going. So if we wanted to add like a locomotion state, I could go over here and hit this thing and say, okay, here's a loco state. Now you'll see the character is going to enter into T-pose right away because there's nothing in here. It's empty, and the live edit is happening. But there's also nothing telling this transition whether it should be taken or not. So it's just going to take it. So first, let's kind of complete this loop so we can go back from locomotion into idle. So I have a state that takes me to locomotion, and now a state that takes me out of locomotion back to idle. And now that Boolean that Marian has created for us, input left stick, which tells me basically when this stick is in the movement area, this thing will be set to true. This thing so we can tell the stateful to read this and do something when it's set to true. So in this case, we're saying, okay, well, you can go from idle to loco when the input left stick is true, and likewise, when input left stick is false, it can come out. So now if we go over to our game and we play, well, we don't have any animation in there, but if I go and do that, let's grab, which one is this one? This one. Let's drop this in here. Okay, so now it's going to go into a state and actually play something. There we go. So it'll work. Cool.
All right.
The running in a straight line game.
Yeah, that's exciting.
It's a great game.
Yeah. We'll ship that one.
All right.
All right, I'll one up to one, and I'll go ahead and add steering to this.
Cool.
Right, so we'll make it so that when I push my stick in different directions, the character will actually go in that direction. This is real easy to do here. I'll just right-click on my animation inside of my state here and go wrap contents in a steering controller. So steering controller is the piece of functionality that comes with the engine that allows me to control facing for the character based on input hookup. And I'll just go ahead and edit this real quick and hook it up to a game state that I already have that detects which direction I'm pushing my stick in. That one's conveniently called input steer, so I've already set that up in the input system. All right, there we go. So now we can run in a circle, or not. Why not? Try do that again.
Let's try it again.
Okay. Yay.
I don't know why that.
Okay, there you go. Awesome. That's why I have an engineer here.
Yeah, you just do it again. Did you unplug and plug that in?
There we go. Yeah.
All right.
Is it plugged in?
Cool. Cool.
Okay, cool. So we have steering.
Yes. Right.
What should we do next?
What about we do jumping?
Okay, go ahead.
Let's do that. So, okay, so character wanted to jump. So if I wanted to kind of keep building in this sort of state machine, I can continue to add stuff to the state. So in this case, let's say I want to go from locomotion to jump. I could just create a new node the way I did before, or I could do something cool. Let's see, I could go find the jump animation that I want, this one, jump from loco. I drag and drop it here. And what's happened here is that it basically, it's kind of done all that steps for me. So it's created a new node and put the controller in there for me already. So I'll just name this and also create the loop back to loco. So now I have these states, and likewise, I'm going to need to have some conditions to guide this thing. So we've already set this up in that input system that we had shown before, input jump. So I'm going to say, okay, well, from loco to jump, I'm going to say, not input fire, input jump has to be true. And likewise, from jump back to loco, this thing has to be false. Well, I don't know any better, so I'm just going to do that. So now when I play this thing, if I hit this, there we go. So if I hold this button, the jump seems to complete. But when I just let go, it seems to come right out. So the issue here is, as Marian is smirking, this condition here isn't actually correct. I don't want to just come out as soon as the Boolean is set to false. In fact, that's kind of problematic. So I can remove this, and instead I can say, okay, well, hey, stateflow, why don't you wait until this animation is done and then go to the start of the next one. And so that way I can just one-shot this. So as soon as I hit this, I will do the jump. And as soon as I let go, the jump will come out. And now it looks perfect.
Yeah. So I think you've created a bug option.
I prefer to call it a visual artifact, but yes.
Yeah, that's what we call it in the industry,
right.
visual artifact.
Okay.
All right, so let's imagine for a moment that we've actually built something a lot more complicated here, that we're in the middle of a real game production, right? And we have many states and like 100 animations, and I've just tested my game and I found this stutter step. In that case, I would probably want some pretty heavy-duty debugging tools to find out like exactly where this bug is occurring. So we thought right now we'd take the opportunity to show those off. So I'm going to open this thing called the animation debugger.
No, it's tapping back.
Okay, here it is. You can tell from its interface that this does a lot of things. We're only going to show off one of them. So the first thing I'm going to do is attach this thing to my character in my game here. And so now it's reading basically just the information from him. And then the next thing I'm going to do is open this thing called the controller debugger. So put it up here. All right. So now what I can do is I can hit this record button down here and start playing my game and try to reproduce my bug. There it is. I'll just make it happen a couple of times. All right. And I'll pause this. Okay, so the thing we have now up here, for one, I can now go and scrub backwards in my game and see exactly what I've done. Find my bug again. There it is. And what I have up here is a representation of the controller tree that we've just built. Right? So this shows me exactly what has been happening, in this case, before and after the visual artifact that we're trying to debug here. So in this case, we know that we've been in the jump state before, and we're going into the local state after the problem. This also shows me exactly the animations that are involved in the problem. So in this case, the jump animation and the run animation. We already knew that, but it's nice to see that in here. And if we scrub through here, we can see that the bug is occurring right in the transition between those two states. Right? So now that I have that information, I can shut this thing down carefully.
Right. And we could probably do a whole talk about like what this system does and all the different kinds of debugging you could do. You could look at memory in the animation system. You can look at various things like that. But yeah, this is just scratching really the surface of what this little tool can do.
Okay. And so now what I can do is I know which animations are causing the problem. Right? So I can go maybe open those up, investigate, and investigate them to see if I can fix the issue. So let's look at this run animation first. Right? This is what we're blending into. So probably the first 8 frames of this, sort of where the problem is occurring. It starts in this passing pose, left foot on the ground, right, and the right leg is swinging forward while doing the blend. And we're blending that with the last frame of this jump clip, which is the opposite passing pose. That's obviously never going to work, so that's where our stutter step is coming from. So in order to fix this, what I can do is I can go in here and find a corresponding pose in this clip, maybe, somewhere around here, and then add what's called a branch window. So I'll add a branch out window into this clip. I'll give it a name. And drag this up a little bit so you guys can see what's going on. So here's my tag. And I'll also add a branch in window to this run animation. Oops, that was a point. I did not want that.
That'll work.
Okay, that'll work. All right. No, actually, I do want the other thing. Okay. Yeah, branch in window. Okay, give it a name. All right, so now that I have my 2 windows here, I can now go into my state flow and replace this into start tag that Afshin made.
No.
I know you love it, but we'll replace it. And I'll just tell my transition that, no, you actually have to use my branch windows. Okay. Now when I test this, yay, no more stutter step, and this looks good.
So like it kind of, someone might wonder, like, why would you use branch windows and not just, like, I don't know, trim the clip and blend out at that point? Like, what's the point of all this markup?
Well, so this jump animation might be used in many different places, right? So I might actually, in other places, I might actually want that back bit here. So I don't really just want to cut it off. So it's partially about reuse. It's also like I also wouldn't want to duplicate this all over the place and have many different versions. That's hard to manage, and could create performance problems.
Right.
So if you put a lot of these branch windows in there, then this clip sort of stays intact, but we can use it in many different places.
Awesome. Cool. So I guess there's one last little thing that might be nagging people, and that's the fact that this robot really looks like a robot when he's rotating around. So what do you think we could do to make that look a little more natural?
Why don't we add some leaning to that? How's that?
Sure.
A little more physically plausible.
Sounds hard, so maybe.
Okay, so I do have a leaning animation here.
Okay.
This was mocapped. Let me see what that looks like. Okay, so this leaning animation is kind of nice. He actually does lean, but it does go in a circle, and that is not really what we need. We want an animation that we can blend with this run cycle, which goes in a straight line, right? So what I'm going to do, like usually, like if you found yourself in this situation, you'd probably go back into Maya and fix this up, but we don't have Maya on this laptop.
But we have Frostbite.
But we have Frostbite.
So
I'm just going to take the opportunity here to show off the layers controller. We can just fix this up real quickly by combining the straight run and this turning animation. So I'm just going to make a new layers controller. I'll add the straight run as the base layer. There it is. Okay, there we go. So now, right now, this just plays back my straight run. Right? And then what I'm going to do is I'll keep the animation on the root, which translates my character forward. And I'll just replace the animation on the character's body with the lean right animation from the other clip. So I'm just going to go and grab, lean left animation, actually, sorry. So I'll drag my lean left animation in here, and then mask this. Now I already have a mask set up here that basically takes all of the, plays all of the animation on the body, but masks out the root. Okay, and what I have, there we go, is an animation of him leaning and running straight forward. Totally physically impossible, but hey.
I can do that.
Can you? I want to see you do that. Show me later. All right, I already have the right version of this set up, so at this point we're ready to go make a blend space. Right, and I blend from the left to the straight upward animation and then back to the right, and then we can put that in the game and replace our run cycle with that. So I'm going to make a blend space. I'll call that run lean. Okay, I'm just going to rescale this a little bit because I know I have to. Frame. There we go. Okay, now we're ready to add animations to this thing. So I'm going to first just drop my run cycle in here. I'll actually drop 2 copies of it in here because I want a little bit of a dead space in the middle so the character doesn't start leaning immediately when I'm starting to go around the corner. And then I'll drop my 2 layers controllers in here that I just made, left on the left side, right on the right side. So this is a pretty cool example, actually, of this controller thing that Afshan was talking about earlier. So, I have 2 layers controllers here and 2 clip controllers, and I can basically use them in exactly the same place, and they will behave exactly the same way. So this shows off kind of nicely how I can combine different types of assets or different types of controllers in the same places. All right, so I can test this out now. Make sure that my blend works properly. No?
Did play.
Yeah. Okay. So let's see. Yeah. Okay. So we can go from left leaning to right leaning. He's veering a little, but oh well. Okay. So that seems to be pretty good. We can take that and drop it into our state flow and replace our run animation with it. And of course, our run animation is now wrapped inside of the steering controller, so I can't just take this and drop it in here. Instead, what I'll need to do is actually replace the run animation inside of the steering controller. So I'll just go back into that and edit it. And up here is listed the thing that it wraps. So I'm just going to go grab my blend space and drop that in here instead. Now it's been replaced right here. And now we can test this out. Let's hope. There we go. Ooh.
Is it not letting?
No, why not? What is going on?
This one thing is having a little bit of an issue. Let's just clear it.
Okay.
Do it again.
Okay.
Try that.
Nope.
Interesting. Well, now you know it's a live demo. All right.
We've done this like 30 times in
Yeah, this is the first time this is happening. So let's try one little quick thing. For those of you who know the animation system, you're going to love this one. All right. Let's do this. Let's try this again. Let's see if that picks it up.
Yeah, this is why I bring engineers with me.
Yep. All right, is it starting up? Come on. Come on. Sorry, just give us a quick second here to... Still hanging out.
That's what it is, okay.
Okay, let's try that now. There we go. Sorry about that. All right, let's see if it works now.
Nope.
Still not working, huh?
Okay.
Okay, well,
fine.
We'll have to move on from this one so we can get to other stuff, but this should have worked. Well, oh well. Well, let's show what this kind of stuff would have looked. Well, actually, we could probably just show this in the editor. We're going to get rid of the game anyway right now.
Oh, that's a good idea.
We can just show this in the editor and show how this looks like. There's probably something up with the live edit system, and it's not showing it well. I hope this actually works here. Yeah, it doesn't look like even that's working. Are we pointing to the right state flow? Probably not. Oh well. Okay, well, let's take a look at what this kind of, some of what we've just built right now would look like if you had built this in a full production. Teams like Anthem and BioWare and FIFA and everyone who uses this kind of stuff, they use exactly the same tools that we've been using today. So this example here is one where we were outside of Fort Tarsis and we decided to fly out, and we have the controller debugger running in the bottom. We have all of these different controller trees running, and you'll see things like layers controllers and things like that happening. It's pretty cool to see, like as an engineer, seeing all your tools being used in full production. And the depth of this controller tree is pretty cool. Like you can see the scroll bar on the right-hand side here, how many controllers are happening all at once in this game. And even things like pausing the game that Marian just did and like scrubbing back and moving forward. All that stuff is just working at scale. So it's pretty awesome to see. Yeah.
Yep.
Cool. So we're going to move on to like another type of locomotion that we've been experimenting with at EA. And it was kind of alluded to earlier today with Dan's talk with motion matching. So maybe, Marian, you want to give us a quick intro into what that is all about and what that looks like.
Okay, sure. So if you just saw like that controller tree from Anthem, you can imagine like how incredibly long like an animator would probably have to work on that setup. Can you close this off?
Yeah, go ahead.
So you can imagine how long it would take to set something like that up. It's probably weeks or months of work, right? And we're always looking to like make things easier for ourselves. So lately in the industry in general, and in EA in particular, like there's been this new sort of workflow that allows us to synthesize animation. So in our tools, this tool is called motion synthesis. And the way you work with it is the basic idea behind it is basically this. So if you, let's say you were trying to put together a locomotion system, what you would do is you'd go into either Motion Capture Studio or you'd hand animate a representative sort of set of motions that express what that motion is. So for locomotion, for example, you'd go do walking, running, walking in circles, starting, stopping, sharp turns, whatever it is that goes into somebody moving about in space, right? So I brought in a representative motion set here. This is probably about 110 animations or so. Let me see, actually bring the actual setup right here. So this is, it says 140 up here, but it's really 110. I'm not using some of them. So once you have the set and you have it cleaned up and like ready to go, you would go ahead and put that into a database. So I brought one in here. I'm not going to build one in front of you because it's actually not that interesting to watch. It's basically just dragging clips over. So once that's opened,
there's a lot of animation.
There's a lot of animation in here, so it takes a little bit to open. Once that opened, you'll see that what's going on inside of that database is that the animations are categorized into different buckets. So there'll be like, here it comes. So there's like starts and stops, drastic turns, cycles, idles. This is mostly just to make the database go faster. There's a little bit of markup that goes into here too, so we're telling the animations whether they can be mirrored, whether they can be looping, those kinds of things. This database has a few nice usability features, like I can click on a clip in here, and it will bring the clip up immediately, and I can play it back. If it's mirrored, it shows me both versions. I can also select many clips at the same time, and kind of play those back, make sure that I have all the angles covered that I want to cover. So these are sharp turns right here. So once I've set this up, and there's a number of other tuning variables that go in here. Basically, what happens underneath is that there's a system that figures out at each frame what the next frame should be out of all of the frames that are in here, based on what the character's just done and what he's about to do. Right. And if I'm building a locomotion system, I can then take this and put it into a locomotion controller, motion synthesis locomotion controller. I'll just make a new one of those right now. Okay, so that's what it looks like. And we can populate that with our database. We'll throw a few tuning variables in here. Doesn't really matter what exactly those are. It's basically things about like how fast can a character turn, those kinds of things.
I heard they come to you in a dream.
Hey, I meditate on it, and then we put those in. So what I'm doing here is actually not, usually a technical animator would figure these kinds of tuning values out at the beginning of a project and then give them to the animators as sort of starting values, and then they'd go from there and refine them. But like setting it up, this is not too unrealistic what I'm doing here. And then I would go and also throw a path in here. All right, and now I'm basically done. And we can start testing this. So here's my character, and I have what I now have is a pretty full-featured, pretty nicely reactive locomotion system. And this guy has nice starts and stops. He can do these nice turns when he does bank. And he looks along the path that he's going in, and so on and so forth. Right. So this gets me probably about like just this little bit of work that I've just done right now, and in a real production situation, this would probably be maybe half a day's worth of work with setting up the database. So this gets me about 85–90% towards a full-featured, really nice locomotion system. So compared to weeks or months on a controller tree, that's a pretty nice improvement. Right, so that's cool. Motion synthesis.
Right.
A few things to say.
I was going to say something, but I was just thinking about this. Did we set up the float on the blend space?
Oh, maybe that's what we did.
Maybe that's okay.
Aha.
So, because we can't get this wrong.
All right.
So yeah, it was this one, right? This one.
Yes, that one.
So that's the issue.
Okay.
So now, I mean, we could run the game, but like we'll just run this one.
Okay. There we go.
So this is just the previous example with the leading that marionettes.
Yeah. It does work.
It does work. Okay. Good.
Here's the error.
Good Frostbite. All right. So, well, we should have debugging tools to let us do this.
Well, we're engineers that tell me what I'm doing wrong.
So, So what's really cool, so we had this sort of whole leaning thing happening and stuff like that, but what I really like about this motion synthesis setup is that it's just another controller that you can substitute in the state graph. You don't need to replace the state graph. In this case, like we have like jump and stuff like that, so I'm going to take Marion's controller and drop it in and replace that steering controller that we had before. So like you don't need to necessarily, you could still have your previous things going. You could have, let's say you had physics and ragdoll that you wanted to transition to. You could still have that things there. This thing just plugs in into where it makes sense and where it looks good, and then you can use it there. So we can run this here, and you'll kind of get the same thing. And then, well, Mary, why don't you do the jump stuff there?
Oh, sure.
Yeah.
So we can still jump, but we can use the motion synthesis locomotion. There we go.
Yeah.
So if we use this, like you would probably then integrate it a little nicer into the state machine. There's some things you need to do to transition to make it really work nicely. But it's very seamless and integrates very nicely into the system.
And the last thing I'll say about the motion synthesis stuff, what I really like about its development was that it actually wasn't developed by the Frostbite animation team. It was developed by a team under the EA Sports, which is headed by Paul McComas, if you know him. And so these folks kind of built this plugin, extending the engine and making it a generic enough plugin that can be shared across multiple studios. And so they kind of exemplified this culture that we're seeing more and more in the studios, which is like game teams thinking, well, okay, if I build something in a generic enough way, we can use the fact that there's extensibility within the engine and share that and make multiple people benefit from that one engineer's work. So we're finding that to be a super awesome culture to be built in the company.
Okay. All right, so we have...
Right.
We've talked a lot about locomotion.
We have.
Hopefully you're not totally bored, but maybe we'll do something more interesting.
Yeah. So why don't we talk about interactions?
Okay, let's build an interaction. So this would basically be an interaction between two characters in a game, and we'll show how we would build that and how we would integrate it into the game.
All right.
Can you build this one?
Sure. Well, I'll start off with the easy stuff. I'll set up a little scene, and Marion's going to make the scene really cool. So we're going to go back to our friend, the sequence that we just were working with before. So one of the features that the sequence editor has, on top of being able to blend animations, is that it can animate multiple actors at the same time. So I can put two actors in here, or two characters. And for now, they're at the same spot. But first thing, let's just make one of them red, so it's easy to differentiate between the two. And then what I'm going to do is going to give each of them a little animation. Where is this one? Okay, so this one goes here. Is that right? Yes.
Yep.
Okay. So one of them is going to do a sort of a pushing thing, and the other one is going to do a fall over as a result of the push thing. Okay, so let's get them out of this position. Oh, not together. Let's just grab this person. All right, there we go. Okay, so like if you just want to just look at the animation side by side, the blue character is sort of stumbling through and the red character is falling. So we want to make it look like the red character is being pushed by the blue character. So I'll just kind of move them into position here so that they more or less resemble what we want. Okay, let's see this. There you go. Okay, does that look reasonable, Marion?
Play it again. Yeah.
Okay. All right.
Sorry, animator kicking in.
All right.
Yeah, red. Come on.
There you go.
Yeah, okay.
Okay.
We have sort of an impact. That's good enough. By the way, so usually in a real production situation, we would, like animators would actually animate a real scene in Maya with several characters, and then we'd bring it in here. We'd still assemble it inside of Sequence, though, in the same way that we're working with this here.
Yeah.
Okay.
And so the last thing we need to do, right?
Yes,
we have to still, right, we got to do that. So the last thing we need to do is we kind of need to mark this sequence up to be used by the system that Marion's about to build. So this markup, you can kind of think of it as like we're going to assign roles to these characters in a play. So like this character is going to be the attacker, and then this character is going to be an enemy, although I kind of prefer to think of him as misunderstood. But like, whatever your frame of reference might be. So we've assigned these roles, and then now we kind of got to get this hooked into the system.
Okay.
Right.
So basically our goal is to be able to take the scene and dynamically play it inside of the game and integrate it with all of the gameplay that's going on around it. And the system that we're using to do that with is called Scenario.
Why don't we set up the states first to use the right
Oh,
state
okay,
machine?
okay,
Yeah.
sure, yeah. Okay. Threw my flow off. So I'm actually going to switch state flows real quick here because there's a little bit of hookup that we needed to do to make this work properly, and I don't want to build state machines in front of you all day. So we'll switch state machines, and we'll also make our characters use our new state flow here. Okay. All right, now we're ready. Cool. All right, so scenario. Scenario is basically a way to define the conditions under which a multi-actor interaction can run in the game. And it also allows the animators to define how characters enter and how characters exit an interaction like that. So it has this thing in it called the alignment driver that allows us to exactly define what the blending looks like and when characters have to be aligned. So I'm just going to make a new one of those in here. I'll set it up with the same roles that Afshin has just set up for his scene. So when this comes in, it already knows that there's attackers and enemies that we have to deal with. I'm just going to flip a couple of switches to make this easier to deal with here. Okay. And so the first thing we need to do is take the scenario and actually tell it what content to play. So I'll go and find the scene that you made. Was it this one?
Oh, oops. I don't know. Let's
Yeah.
just right-click on that one and select it in there.
Okay. Select the master.
I give really meaningful names.
Awesome. So, okay, go back to a scenario. And drag that in here. Okay. So now our scenario knows what the content is it should be playing. And then in order for us to be able to test it properly, we need to actually hook it up in the state flow. So we'll drag that over. And the state flow node has now turned orange, which is sort of the alert for me as an animator that this node is special. And the way it is special is I don't have to define the conditions under which I can enter into this node. Instead, it inherits that from the scenario controller. Right. So if we, what we've now done is we've set up the scenario with content, but we haven't actually defined any rules yet. So if we go ahead and test this now, let's just see what happens. So I have a scene with a couple of characters in here. Collapse this a little bit so we can see what's going on. We have blue and red in here, and I'll just hit play. There we go. Okay, so my scene plays, that's good. But it keeps playing over and over and over again, right, because I haven't told the game under which conditions this can play. Also, the characters warp really far to get into position. So the next thing I'm going to want to do is actually set up some rules for when this can play in my game. And the specific one that I'm going to want to set up is I'm going to want to say that the characters have to be in exactly the same spatial configuration as they were in the scene that Afshin set up. So blue is slightly behind and to the right of red. Scenario allows me to do that really easily by just going in and flipping a little switch over here. And once I do that, it also gives me this nice graphic representation of the rule that it's just made. I'm also just going to add facing to this real quick. There we go. Okay, so here this conveniently blue-colored arrow represents the blue character, right? And red represents the red character. The arrows are in the same in the positions that the characters are in the original scene, like this. And the other thing I have in the scene here is this little blue wedge here. And what this is a trigger area. So basically, if you imagine that I'm running blue around the scene and I'm trying to bowl red over, it's pretty unlikely for me to exactly get into the positions that Afshin set up, right? So we actually want to create sort of fuzzy conditions. So what this trigger area is an area that if red is in here, we will enter into the interaction. And if red isn't exactly in the right position, he is going to, the system is going to translate and rotate him so that he does align properly. And a lot of, then what scenario actually does is it allows the animator a lot of control over what that, like when the characters have to really be aligned and what that blending looks like during this warping area time. Okay, so now that I have this set up, I can go back into my test scene and test this out. If I play it like this, nothing will happen because red isn't in the trigger area. I get this nice sort of debug display that tells me where the area is. And I can take my actor and move him in here. Maybe like this. And test this. So now it plays, and then it won't play again because we're now not in the correct spatial position. Do you want to do the honors here?
Sure. Well, now you can run around in the test scene here as well and just do this thing. So basically Marion's thing works. And it's cool because like when they're not in that space, even if the character's in that area, but their facing are not matching, you'll see that it won't play. But yeah, when I get into that setup again, it'll work. So it's pretty cool.
Yeah, that's pretty cool. So I did want to, because this came up in an earlier talk, I did want to maybe show just real quickly, and I won't actually demo that, but I do at least want to go into that panel and show you what that looks like. Scenario gives the animator a lot of really nice controls over the actual alignment and what happens during the alignment. So I'm just going to open that up and show you what that tool looks like. Basically, so in here I have sort of this representation of a timeline. And I can drag these little widgets around. So this area right here, like this is how I would define where in the interaction my characters have to be perfectly aligned. Right? And this green area in front of it is the time during which we translate and rotate the characters in the game and sort of warp them into the interaction. And there's a lot more in here. Basically, a lot of really fine controls over like when characters can join. I can determine in here whether somebody can late join, so if somebody can join this interaction when it's already going. If there's several characters in there, I can also say who has to be there and who is optional, and so on and so forth. So this is a really nice tool for sort of very dynamically integrating little scenes like that into gameplay. And just to show you like what that looks like in a real finished game, if a real master wields this thing. Here's a scene from Madden. Madden uses this pretty extensively. So this tackle here and this takedown are all scenes that are interactions that are controlled by scenario. And you can, if you see what's happening here, so the enemy players, or basically the players from the other team, are going after the ball bearer. And as they're going into, if you watch this, as they're going into position, like right here, they trigger the tackle, which is an animated multiplayer scene. Right? And this, I really think that this looks really good. You know, it sort of dynamically integrates into the gameplay in a fashion that's really visually pleasing. And I think the reason for that is that the scenario mechanism itself in Frostbite gives the animators just a really huge amount of control over how we join these scenes and how we get back out of them.
Awesome.
Yep.
Cool. So we have like just under 10 minutes, I think, left. And we thought we'd have a little bit of fun, because we weren't before that, to talk about one of the cool systems we have, which is expressions. And so maybe we will do that in the context of making our little two-person thing into a little game, where whenever we push the red character down, you get a point. Sounds like a really fun game. So we're going to show this using the expression system. So expressions is basically a visual scripting and kind of programming language that exists in the Frostbite animation system. And yeah, it basically lets you read from anything in the animation system, do something with it, and write it back out somewhere else. So we'll just kind of use that to do some fun stuff. So the first thing we want to do is get some text on the screen to represent the points. So we can create a little text node here. And we'll say that the text node, so what we're going to do is we're going to keep track of the points with a floating point game state called points, or point. And if I drag that into here, I can say, okay, well, I want to read from this, so I'll read from it, and that'll be the text that we write to. And if you look now in the little scene, there's a 000 now in the middle, but it's at the origin, right? It's not really going along with the characters. And what I really want is to have these points carry around with my character. So what I want to do is look at my character and read a joint of him. Now, I can read any joint I want. I can kind of go through the entire skeleton and have a look at, spine, leg, I can go all the way down. In this case, it probably makes sense to just look at the root, which is the AI trajectory. So we'll bring this along here and say, okay, well, the position should be, maybe it should be at the AI trajectory. And now the character, as we move around, the 000 goes along with it, but it's kind of mixed up with all the debug lines and stuff like that. So maybe we'll kind of do a little vector math here and translate the vertical coordinate here to be a little bit above, so maybe it sticks above the character's head instead of being at their feet. So we can just go over here and say, okay, well, take this vector, add 2 to it, or add 2 to the translation rather, and make that thing be the position that we write. And now we have these at the top. So now that the basic stuff is done, Marian, why don't you do the real actual gameplay loop?
You're going to make me program.
Yes.
We've switched roles here completely now. All right, cool. So what our goal here is, right, to have a score. So we want to count this up 1 every time our interaction runs. And so the way I'm going to do that is I'll go in and find the animation that, say, Blue plays when he runs our multiplayer interaction. And I'll put a marker in here. So what I'll do is I'll add a tag. This is a Boolean game state tag. And I'll just pick a random Boolean I have sitting around. And now what happens is this Boolean is false by default, but when I hit this tag, it will become true for 1 frame. And that is how I can detect that this animation has played. Right? So now that I have this hook into my animation system, I can go back to expressions and then find my Boolean over here. Drag it over and read from it. And then I'll just make a condition node. You tell me if I do something dumb. Okay, I'll make a condition node. And so now this allows me to branch on whether this Boolean is true or false. Right? And what I want to do is find my points variable, the one that keeps score, and write out to it. So get a writer for that. When my Boolean is false, I'm just going to want to write the same value back into points. So I'm just going to get a reader and drop that down here. But if my Boolean is true, I'm going to want to add 1 to that. So I'm going to make a float. Make its value 1. Right. And then get an add node. All right. And we'll be like really game state reader. This will be really inefficient. And just put another reader in here.
This is the real game.
Oh yeah, totally. And so we'll take 1, add it to point, and then feed that into a true condition here. So now what happens is on that 1 frame that my Boolean is true, I'm adding 1 to my score here. All right. Yay, I programmed the thing.
Awesome, let's see.
So let's see if it works. Yeah, we already have a point.
Let's zoom in a bit.
Okay, 2.
All right, can we get to 3? Yes,
3, okay.
It works.
Yeah,
All
we have a game.
All right, cool. This is the game. This is
Yeah,
really
totally.
the next game.
So this is a little silly, obviously, right? So I mean, the expression system isn't really made for this, but you can actually do some serious stuff with this. It's a full-fledged programming system, right? So if you're, for example, a technical animator and you're trying to work on a feature and there's something missing that you really need, this makes it so don't really have to go to somebody like Afshin and have them write a thing for you, right? So for example, for the leaning thing, when I was prototyping that earlier, I didn't really have the capability in our system to figure out how far or how fast the character is turning. So I just wrote this thing in expressions that basically goes and figures out frame over frame how different the facing is of the character. And then it also, in the next step, it figures out whether the character is turning left or right. And then it does a little bit of smoothing, right? And I pumped that into this variable called lean turn angle that we then used in the blend space that Afshin nicely put back into the blend space for me. So this is a real piece of math, right? That theoretically then could ship in a game, and we do ship games with the expressions actually running like that.
Yeah.
Afshin would probably go in and make this run faster for me, optimize it. Or like if it's a heavy piece of math, he might actually also go in and just look at what I did there and then write a piece of C++ that makes a note for me.
Yeah, like these nodes are all extensible, so we can like take this logic, write it in a kind of like subclass sort of thing, and just create a new node that not only might be more optimal, but it might not be. But the real benefit there is that you can just reuse that piece of logic anywhere as a separate node. So like imagine if I was writing the conditional node that we used here. We could just plop that anywhere and reuse it over and over again. Okay. So yeah.
Yeah. Hey.
Okay.
So hopefully that was pretty much the end of the demo. Right?
Yeah.
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 Hopefully you've enjoyed this.
Yeah, we did.
We did.
Yeah. And like, yeah, I mean, this is just sort of like a fraction of the Frostbite animation system, which in itself is sort of just a component of Frostbite. There's lots of other things like Ludo over there just did a talk yesterday on Frostbite cinematics. There's so many different components to Frostbite. So if you're interested in what Frostbite is and what we do, if you're here, come and talk to us or anyone here who's from Frostbite and EA. And if you're on the stream, we'll send out, or I think we already did send out a link to a video to show what we're all about. So yeah, get in touch with us.
I wanted to say one more thing too. So if you're interested in scenario, there was actually a talk at GDC 2 years ago, at 2017, that Henry Allen gave, who's the lead programmer on that system. And so if you're interested in like how, in finding out a little more detail about how that works and how it's set up, and you have access to the GDC vault, you can go and find that talk and take a look at it. It's really interesting. It's a very deep and very powerful system.
Great. Thank you very much for your time.
Okay.
It's just me. I'm going to make up answers to questions that I haven't asked them yet. And, oh, they're here. I guess now I have to actually talk to real people. Oops. Hi.
Hey.
How are you doing? I think you are done with that, and we'll put a headset on. Okay. And put that there. And we'll wait for Afshin to get his headset on. It's all right. We're good. All right. Hi.
Hello.
Hi.
Hello.
Hi. I'm Tim. I'm back again. You all know me from the previous interview where I tried to get Rick Arroyo to embarrass himself and probably only embarrass myself. That's all right. I'm here with the speakers from the previous talk with Marion and Afshin. Hi. How do you guys feel like it went? I think it went great.
Ah.
Yeah, it went okay.
Yeah, I think it went a lot better than you think it did. We have a lot of great questions from the chat, and we'll get to those. And we have a couple other questions that I want to ask just from watching it and from talking to you prior. So we're going to do that now while they set up for the next talk. I'm going to be looking over there because that's where they are. Maybe we can roll them like right here.
Ah.
And are they in frame? Can you still see? We're good? All right, we're going to keep them right there. So let's see. Actually, the first one is probably a good one because it feeds right off of the last bit of stuff that you were showing. From Furious Cabbage. How much responsibilities do the animators have during production to build those state machines, and who's ultimately responsible for creating and maintaining them?
Do you want to take that one?
How much responsibility? I mean, usually complete. completely. Like usually you'll have someone like Marion who's a bit more of a technical animator setting those things up. It's usually in consultation with engineers to sort of just understand what the performance impacts might be of some decisions and whatnot. But usually you'll have sort of more senior or technical animators doing that, and people might have certain states or areas within, because you can have multiple state flows nested within each other and whatnot, so you can kind of siphon off a section, one sub-state machine to be controlled by some animators and some by the other, so it's sort of usually in the content creator realm.
All right. So do you like find like when people come onto a project and they're just starting to learn Frostbite, like what do you feel like the ramp up time is for somebody? Like how do you guys kind of work that in, especially if you've got, you know, team members who want to be more technical and try things out in it, you know, that maybe they haven't before. So what's kind of like, how do you guys handle that, the ramp up time?
So that's a good question. I can speak to that because I've actually just gone through that process. So in my experience, ramp up time for that system to like the point where you're competent and you can actually be productive in the system is probably comparable to other animation engines that I've worked with before. Okay. So it's not really super complicated. You know, once you kind of grasp the basic concepts, it's pretty quick to pick up. Okay. Then on the other side, like if you really want to be a power user or a really senior technical animator, the system goes very deep in very many places. Right? So we've seen a little bit of that in scenario. Same thing for motion synthesis. So you can, it's sort of a lifetime of learning situation in that case. Okay. So yeah, that's probably. That's cool.
And do you do you have a lot of I know like animators nowadays, like we want to get our hands on like everything, and we want to we have it in our heads how we want something to look, and working with gameplay, and so like do you find yourselves having like every animator who comes on wants to ramp up and learn a whole lot, or do you kind of like, is it like since the tools are there, or is it more like some people just still want to animate and some are really more into the technical aspects, like?
I'd say it's probably the latter. Right? Okay. So depending on the personality of the animator, some people are more technical and are really interested in making animations function well in the game, and others, others want to concentrate on just creating the art. But awesome. The system is definitely geared more towards the more technical people.
Awesome. Let's see if we got any other here. So how about talking about you've got people who come onto the project and there are new features that the project might need that aren't necessarily in Frostbite, but they're going to be something that needs to be developed. What's like your process for not just like taking those requests, but then designing the feature and iterating and everything?
Yeah, so I think the first thing that we would usually do is go through sort of a requirements gathering phase with the people specifically asking for it, and sort of understand what the use case is and whether what they're suggesting is what actually is going to solve that use case. Really, what as an engineer, like when we get those kinds of requests, we really we get into the understanding that we're not going to be the end users of the tool that we are going to be building. So we really go through a process of trying to get the content creator involved as soon as possible. So usually with a feature that we want to build, after the requirements gathering, what would happen is, sorry, there's a Windows sound in my ear. What would happen is the engineer would go through a rapid prototyping phase, and we're really lucky that we have Marion on the team because we can get immediate feedback on that prototyping phase. Once that prototype is at a place to be used, what we'll do is ship out maybe like a small binary or whatnot out to the animator or content creator who was asking for the feature, but also to their representative counterparts in various different game teams. And we do what we call a usability test. So we have them use it and debug and whatnot. And once that's done, we're kind of ready to push out the first version of the tool. So yeah, that's actually a good example of something that was built like that is the controller debugger that Marion was just using. Nice. Recent example, built exactly that same way.
That's awesome.
Yeah.
Cool. All right. Let's see. Let's do another one I think that we have from the users. All right, what kind of general engine tools would you recommend animators learn in order to best understand the technical implementation for in-engine use? And this is from user Travdar.
General engine tools. So, so if you mean generally available, like publicly available engine tools,
or maybe like things like videos they can watch, or like books, tutorials. You don't have to call out specific engines if you don't want to.
I mean, what I would say is get a hold of one of the freely available
All right.
game engines,
And
and just start playing around in there,
okay.
and try
Yeah.
building things that you think are good, you know,
Right.
and then start going through the tutorials available for that and the publicly available information, and you'll get exposed to a lot of these methods,
Right.
and you know you'll start learning how to think in this way,
Yeah.
and you know that'll expose you to that kind of knowledge.
That's. I think we're in an age right now where we have access to a whole lot of stuff that we didn't like 10, 15 years ago, and a lot of this stuff that's in a lot of different engines is the concepts are the same. It's just different companies and different studios and different engines will just kind of have their own way of implementing them, but it's all for the same end goal of making awesome games.
Basically,
So,
yeah. And making animation look good.
Yeah,
in
yeah.
games, you know.
Oh, you mean I don't just put it from Maya straight in the game? It looks exactly how I want all the time. No?
Nope.
I've been doing this for 20 years. Shit.
I got news for you.
Oh God, that's why I keep losing jobs. All right, let's see. I think I'm looking over there. Are you guys? Oh no. Okay. All right. Well, so the Frostbite obviously is used across a lot of studios.
Mm-hmm.
So how does your team manage cross-studio collaboration? Like, say you've got a studio over here that's using it. Maybe they came up with a feature and a design and everything, and maybe there's a studio across the world that might need that same thing. Is there a lot of like sharing of those ideas? Is there a lot of talk? And I think you guys have summits where you kind of share things. Like
Animation in particular actually has a summit pretty much every year.
Okay.
The senior animators from all the different teams come together in Vancouver.
Okay.
And it's sort of like a mini GDC for EA animators.
Nice.
So people
You mean a
bring
mini animation exchange?
animation exchange. Yeah, so people bring in their solutions. They
Yeah.
they give talks on how they solved certain problems, and there's a lot of discussion around like what the different solutions are. People can bring problems in and discuss how they would be solved. So there's a lot of information getting exchanged there. So
Nice.
it's really beneficial, being able to draw on the expertise of like so many different teams and so many talented people.
Yeah, and Frostbite as a whole does an annual thing as well called Frostbite Dev Days, where we gather a bunch of people from the Frostbite team, and also a majority of the people are from game teams using Frostbite. They gather in Stockholm for a week for basically a slightly less mini GDC, where there are tracks and various different things and animations, cinematics, all the different kinds of domains, and that's really awesome. I mean, at the end of the day, like EA is pretty much a global company. Like there's studios all over the place, so we really value that face-to-face time and being able to share what each team did, share their failures, share their successes, and learn from that. We find that super valuable.
Nice. Awesome. We have a fairly, a little bit more detailed technical question from C. Longmire 42. The question is, can states be transitioned to or retransitioned into via a gameplay event? I know how to read, I swear to God. Via a gameplay event instead of transition logic, therefore cleaning up complex transition logic.
Oh boy.
That's
I mean, I'm not fully familiar with all of that, but the short answer is yes. That happens all the time. Like cinematics does things where they, when they want to enter into animation, exit from animation, they're kind of in their world and they'll send some signal into animation and make that happen. So there are lots of abilities to sort of interrupt the animation system, transition into things, or vice versa. So yeah, that controller is always there.
Nice.
Yeah.
All right. And we have another one from Time SCK. Is that Time Suck? Is it?
Yeah.
That's probably what they want to know if they can be friends with you after.
Yeah, I think if that's who I think it is, I think that's Paul McComas. And
then no.
If it is Paul, then no.
Definitely not.
No, I don't think so.
No, I don't blame you.
But if it is someone else, I'm sorry. Yeah. Hit me up.
Let's see. Somebody is asking me how my pup game is going. I can't answer that. That's under NDA.
Yeah.
All right, let's have some fun. Okay.
We're really in the hot seat.
Yeah, I know. Now we're gonna just make some stuff up, and yeah. So
Going off script.
all right. So I'm not gonna ask you either of you like what the worst thing you've ever done in your career is, because I already did that with Rick, and he is no longer talking to me. He actually deleted me from his contacts. I think he blocked me on Twitter. So why don't each of you kind of go over like what got you interested in like animation and game dev?
Sure. So I was in San Francisco in the 90s, and it was kind of a hotbed of animation at the time. There was I don't know if anybody was here during that time, but like one of the big things there was like Spike and Mike's show of animation.
Yeah.
Remember that? Yeah. So that came around every year, and it was like a big movie theater full of animation fans, like watching little crazy shorts, and Oscar-winning shorts and stuff. And right around the same time, like Pixar came out with Toy Story.
Oh yeah.
It's like so right around this area, like 3D animation was becoming a really big thing, and so I decided to go back to school, and animation was what I wanted to do.
Nice.
And I actually found this really great program where I could learn 2D animation and puppet animation. I made a puppet film and
Nice.
3D animation, and they had a lab full of SGIs.
Oh yeah. That's
running soft
yeah, that
homage.
sounds- yeah,
So,
I remember those.
Yeah, and after that, this is totally dating me. So after that, one of my teachers recommended me to a small game studio, and I started doing game animation, and I kind of started getting obsessed with making game animation look better.
Okay.
There was like methods for getting it to look like closer to what film looked like, and that's been sort of a quest of mine ever since.
Nice. That's awesome. To be like, just so you feel fine. When I was learning, like when I wanted to animate that's when Toy Story came out, and I was using SGIs using Alias Power Animator 7.5.5.
Oh my God!
So
okay.
I'm yeah.
We should go have a beer afterwards.
We should go cry into them too. Yeah. All right, Afshin, how about you?
All right. So me, I started off I don't have a degree in computer science or animation or anything like that. I started off as in engineering physics, so I wanted to be a particle physicist. I didn't want to have anything to do with games. As that kind of went and got my degree, I realized it's not something that interests me for various reasons. We can have a beer about that.
All right.
So I also had a lot of interest in the arts. I used to kind of dabble in theater, and I really appreciated the arts. So kind of finding animation specifically and seeing sort of the application of all this sort of math and physics and rigmarole that I learned kind of being used in this artistic, interesting way to create motion and sort of all that kind of stuff was a great middle ground for me. So yeah. That's kind of my entry point, and I kind of got an internship at EA. That's how I started.
Oh, nice.
And from there, I kind of grew into the team and whatnot. And it's really great because like I kind of get to work with artists day to day. That's sort of what we do as engineers. We really we're deeply embedded with the artists and trying to kind of understand how they think and them understanding how we think and sort of working together to build the best kinds of tools for them. So that's always in my day to day now, which is awesome.
Awesome. That's great. Yeah, I started out wanting to be an architect, and then Toy Story came out, and I watched cartoons and a lot when I was growing up, and I was just too lazy to learn how to draw. So, and I was like, oh, I can do it on a computer. They draw for me, and then I didn't fucking know that it was a whole lot of other work to do. Nope, that's a lot of work. Yeah, I still don't know, but it's all right. So, oh my God, do you just want me to give you a piece of taffy so you can just keep doing it? This is the length. This is the long. You have to lengthen your yeah. Anyway, hi.
Hey, how's it going?
How you doing?
Yeah,
Good. Yeah. Let's see. Let's talk about what piece of game animation kind of inspires you the most. Like, all right, to follow up with you, Marion. Like, you said you work on, you've wanted to like try and make animation get closer and closer to film and like raise the quality level of like what have you seen that like kind of inspires you to push further that quality level in games these days or even in the past?
Well, so you have to say Last of Us, right? When
yeah.
when you talk about that, so that was definitely a high point,
Yeah.
I do remember though. I don't know if that's a good thing, but I do remember when Rayman came out, the new Rayman version of Ubisoft. When was that? Like, it was a while ago now.
Yeah.
Like 5 years or so. I really loved like the squash and stretch and really cartoony stuff that they did in there.
Yeah.
I thought that was really great. And it was 2D, of course. That wasn't really 3D, but that was something that I thought was really cool, and the sort of the innovative methods that they used to put all that together was
awesome.
That I really liked that.
Awesome.
Your turn.
It's my turn. Okay.
Your turn.
I played this tiny little game a while ago from this Polish studio called Bound. I don't know if anyone's heard of it. It's sort of like a platformer, but the premise is that you're this character and she's a dancer, and she kind of dances through the various challenges in there. And as you can imagine, with a dancing mechanic, that's sort of a great opportunity to have great animation, and they really took that opportunity. And that game was something where you could just feel like you sort of like feel your way through with the controller, and everything you do sort of naturally blends into her different dance moves and her sort of it's kind of like a ballet, so sort of smoothly going through the different things. I thought that was an amazing piece of animation.
Awesome. Nice. For me, it was Mark of Cree. It was like, it's a PS2 game, came out. It was like super Disney-esque style, like animation. Oh my god, it's so good. If you ever want to make Mike Jungbluth go crazy in the head, tell him how much you hate Mark of Cree, and then just watch him explode. It's so much fun. So, yeah. And it seems like we are ready to go with the next presentation. This is a live mocap shoot